All right, welcome back. So previously we've gotten to understand that we have some problem over there, and then we understand that there are people who are trying to solve these kind of problems with which is existing with recurrent neural network. Okay, so we've considered different variants of this recurrent. Okay, and then we got to understand that we have a problem called long-term dependencies. Okay, where if the words are very close to, the word that we want to predict is close to the context, then we can easily use our RNN to predict it. Okay, but if there's a case where the distance between the context word and also the target word is very huge, then it becomes quite difficult for the recurrent neural network to make an accurate prediction. Okay, so we're saying that there are variants of this recurrent neural network. Okay, we saw the various architectures that we have, which is bidirectional recurrent neural network. We also saw GPRUs, and we talked about shortly about LSTMs. Okay, so now what we're going to do next is to focus on this LSTM and try to understand how it works and why it's a breakthrough for us. All right, so as I said, I've given you the paper over here. You can just click on that to read about this LSTM. All right, so let's get to understand what we use LSTM for, right? So we use it to address the vanishing gradient problem, right? And it has three gates, which is the input, output, and then forget gate. Okay, we're going to understand what this means, what input, output, and then forget gate means in the next sessions. All right, so let's try to understand these LSTMs. All right. So as I mentioned earlier on, LSTMs are used to address the long-term dependency problem that we mentioned earlier, right? They are actually designed to avoid the long-term dependency problem. Okay, they actually have the capacity to remember information for long periods of time. Okay, now if you have a problem statement where the previous state, okay, when I'm talking about the previous state, I'm talking about the previous information, okay, which is influencing the current prediction, is not in the recent past, okay, then the RNN model may not be able to accurately predict the current state. Okay, so earlier on we saw the long-term dependencies. We said that if the information is not that close, then RNN model will not be able to accurately, it's not that it's not going to predict, it's going to predict, but the accuracy of it is also important. Okay, and it's possible that it may not be able to accurately predict that, the information. Okay, so if you take, for instance, let's take this sentence here. So we're saying that Alice is allergic to nuts. She can't eat peanut butter. So this is the sentence that we have. Okay, all the corpus that we have Alice is allergic to nuts, and then she can't eat peanut butter. Okay, now the context of nut allergy here can help us anticipate the food that cannot be eaten. Okay, which in this case, the food that cannot be eaten contains nuts. We can anticipate that the food that Alice cannot be eaten contains nuts, right? Because we are saying that Alice is allergic to nuts, which implies that it's possible that she cannot eat food that contains nuts, right? However, if that context was a few sentences prior, okay, that is, if it is just a few sentences away from, that is, if this sentence here, Alice is allergic to nuts, is just a few, sentence away from peanut butter, then the RNN model will be able to connect the information, okay, because it can easily use the clue of allergic to nuts to predict peanut butter, okay. But if this information was somewhere very far, right? For instance, if let's say we are talking about we have this, let's take the text that we have over here, right? Then let's say that this sentence came somewhere here. Okay, so Alice is allergic. Okay, allergic to nuts. Let's say it was the first sentence over here, and then some other sentence came. So this one is no more here. Okay, this one is no more here. Then other sentence came. Then this one comes. She can't eat, and then blah blah blah. This one is not there. Okay, now we need to predict what is going to come here. Okay, we need to predict what is going to come here. Now, since this one is quite far from where this one is. It's going to be very difficult for the RNN model to actually predict, because there are a lot of other words that are here which is going to distract the RNN model from predicting peanut butter over here. Okay, because she can't eat anything. She can't eat rice, right? She can't eat rice. She can't eat banana. She can't eat poison. She can't eat anything. Anything is possible over here, right? Because it doesn't have the context of allergic to nut. It's very far. Okay, it's very far from. I mean, even this one is a short distance, but it could be a long. Corpus, right, or a long document over here with several sentences or several words in there, right? Where maybe Alice is blah blah blah, it will be here, and then she can't eat, it will be somewhere here. So there are a lot of sentences that go in between here, and it's going to be difficult for your RNN model to figure that one out. Okay. All right. So now in that case, the remedy here is LSTMs, okay, which has cells, right, in the hidden layers. All right, it has cells in the hidden layers of the neural network, okay, which has 3 gates. One is input gate, one is output gate, and then the other one is forget gate. Okay, it has these 3 gates, right? Input, output, and then forget gate, right? And these gates control the flow of information which is needed to predict the output. Okay, so in this case, it can keep that information. Alice is allergic to nuts. Okay, you can keep that information in the memory, right? And then finally, when it gets here and then you are saying that, okay, she can't eat blah blah blah, and you should predict the next, it can base on that information that it has kept to predict this one. Okay, to predict this one. So it's quite robust, right? It's quite robust. Let's see the internal workings of this LSTM, right, for better understanding. All right, so this is how the traditional RNN looks like. Okay, we have one RNN like this, which keeps on looping. Remember, we talked about that. Okay, keep on looping. So it's just the same thing, which will repeat itself several times, right? Loop several times. All right, and then we'll have some sort of some simple structure here, such as say tan H layer. Okay, there's some simple structure here, some tan H layer over here. All right, so that is what the recurrent neural network, the simple one, looks like. All right, but LSTM is more robust than just having one single layer inside here, right? LSTM is more robust than that. All right, so let's see how it looks like. LSTM is also having this chain-like structure, okay, but it has a repeating model, right, which has different structure, right? Instead of having just a single neural layer, this one is having 4 of them. Okay, which interacts in a very special way. Okay, so we have 1, 2, 3, and then 4. Okay, 4 layers instead of just having, say, a single tan H like what we were having earlier on. Okay, just a single tan H. In this case, we have sigmoid, tan H, sigmoid. Okay, in this case, all right. That's how the LSTM actually looks like. Okay, so let's actually take it further and then see what these things mean. Okay, what sigmoid here means. You see that we have some circle with some multiplication sign here, some circle with addition sign here. We have some tan H here. We have some arrows going somewhere. Let's try to understand what is going on here. All right. So first, let's understand the symbols that we have inside the the LSTM. Okay, we're actually going to talk about we're actually going to walk through the entire LSTM architecture over here. But first, let's understand what each of the symbols mean. Okay, let's get to understand that, right? So if you see in this yellow rectangles that you have, right, it means neural network layer, right? Remember, in the neural network, we have layers in there, right? Some hidden layers, right? And then we have some output layers over there. So these ones that you see represent, layers, okay? Neural network layer. So here we have the sigmoid layer, tan H layer, and then another sigmoid layer. Okay, and then if you see a circle like this, it means pointwise operation. Okay, pointwise operation. So it can be a multiplication operation or it can be addition operation. Okay, like that. It can be multiplication or addition. Okay, we will see what multiplication means and what addition means in this case. And if you see an arrow just going like this, it means vector transfer. Okay, so for instance, we have some vector transfer over here. Right here, we will get some vectors, okay, some vector values, and then we are transferring, okay. You see where we see arrows like this, it means that the vectors are being transported or transferred throughout, okay, like that. And then if you see the arrows merging at a certain point, it means concatenation. So for instance, one arrow is coming from here, another arrow is coming from here. Here you see that they are merging up. Okay, so it means there's a concatenation over here. All right, and you can see this arrow is going to merge with this arrow. This arrow is going to merge with this arrow as well. So it means concatenation. But if you see the arrows departing from each other, it means that there's a copy, right? So for instance, you can see here, one arrow passed here, another arrow went up here. So there was, a copy over here. Whatever information that was here has been copied up here and copied out here. Okay, something like that, right? In the same way, whatever information that was coming from here, right? Some has been copied straight away out, and then some also went up here like that. Okay, so that's basically what we have. Oh, the same thing over here. Here you see that some information went up, some went straightforward. Here some went up, some went straight, some went up, some went straight. So there's a copy of the information like that. Okay, so that's the symbols that we have over here. All right, now let's try to understand the architecture itself. All right,